Hello everybody, and welcome to my talk at Codeland 2020. I'm Erika Heidi, and I will be presenting the art of programming. I'm very excited to be here, and I hope you enjoy this talk. I'd like to start with a brief story of how I became a software engineer and how I am here today. So it all starts with my parents, of course, back in Brazil. My mother is a Brazilian artist, and my dad is a German engineer. They are very different from each other. My mom is a cat person. She likes all things artistic. And my dad is a dog person, and he enjoys science and engineering and chess. And I was influenced by both of them, of course, but I was more close to my mother, and we would do a lot of artistic things together growing up. So I always thought that I would be an artist, that my career would be somehow related to art. And something changed when I was a teenager, and that was computers. So when we got our first computer at home, everything changed, especially because of the internet. I started using IRC. And that was so awesome. I could connect with other people virtually, and I could write little IRC scripts to do fun things. And actually, I had contact with computers before at school, and I did some coding in Clipper and Pascal. However, it only really started to look like a career for me when I had a computer at home and I could have fun doing coding. So the natural path for me would be to pursue a graduation in computer science, because that was the option that we had at that time. And so I went after that. And that was very, very, very frustrating. I tried very hard. I can assure that. I tried my hardest, but I couldn't get past the math classes. I was very good at coding. I even have a 98 in Java, which is, I can't believe how I did that. It was so hard for me at the time. I found it very difficult, but I managed to get a very good grade. I was very excited about coding, but I couldn't get past math. So I tried a few times. I would abandon the semester and come back the next semester and try again. But it was just not for me. And after some time, I figured that out, and I abandoned the course, the graduation. There was a frustrating experience, and I couldn't really understand, because the idea that coding depends on math, like you have to know math to be a good coder, is so ingrained, and especially at that time, that I couldn't understand really, because my relationship with coding was different. I used to see it. I still see that way. A very creative activity, very creative. You can, create things that are only on your mind, and you can make them kind of real in certain way in a different media. But so I started asking this question: is it programming really all about science and only science, or is it art? Is there art in programming? So I started asking this question. And while reading about it and trying to find more about the beginning, then I started reading about the early days of programming. And this lady here is Margaret Hamilton. So Margaret was very, very important for the project Apollo. And if it wasn't for her contributions, it would take a lot more time for the man to land on the moon. Her code was very important for the landing, especially. And not long ago, in an interview, she talks about it, and she talks about how software engineering was not taken seriously. Software in general was regarded as an art and magic, not real science. So thinking about it and the history and what we read in the books, you can really see that why, and it's evident because the first programmers were women. They would give them this job because it was not considered at the same level at other engineering fields. So, wow, if programming is art, what is art anyways? Maybe it's good that we have a common ground, a definition, because the word art is misused sometimes. There are some misconceptions, or so it's broadly used for many different things. Let's see some definition. The Oxford Dictionary says that art is the works produced by human creative skill and imagination. I think that's a very succinct explanation, and it really focuses on the output produced and also in the creativity and imagination used to produce that output, that work. It's also important to see what artists have to say about art. So Alberto Giacometti was a sculptor, Italian sculptor, and he said that the object of art is not to reproduce reality, but to create a reality of the same intensity. And I think this is really, really interesting because it really resonates with what we do, especially considering social networks. So it's a whole different reality, but it has such an intensity. You cannot say that it's not real life there. It is real life, but it's a reality different from what we live in out of the internet, right? So these are three important aspects of art: creativity and imagination. Art depends heavily on that, of course. Individual expression, also there is an element of individuality, of expressing yourself through art, and in this case through code. If you give a problem to different people, they will all solve it slightly differently. So that is the individual expression you have when you are coding as well. And it also depicts an alternative reality. So not only with social networks or virtual reality, VR, but also just in an application or any application, it has a little reality in there. A little immersion that you can, depending on the application, a game or something like that, you always have some kind of different reality. Also, it's important to demystify what we are meaning here. So in this context, art is not an adjective, it's a noun. It doesn't need to be good, and it doesn't need to be beautiful. So these are all judgments that come after the fact, depending on what people think. It doesn't remove the merit of art. It doesn't disqualify it if you don't find it beautiful, or if it's not useful for you, it's not good for you. It doesn't take away the fact that it's still art. So now let's get back to software. So Margaret Hamilton started to use the term software engineering to distinguish it from other types of engineering. And what happened is that it was an ongoing joke for a long time. So for a long time, so she had to fight for it, and other people after that, so to legitimate software as an engineering field. We take it for granted today, but it was not taken seriously for a long time. The truth about software engineering is that it's still very, very young compared to other engineering fields. It's a baby. It's strongly based on trial and error. Everything we do basically is trial and error with software. And tests cannot be considered mathematical proof. It's still trial and error. The better you test, it's still trial and error. And how often do you hear about a bridge or a building that collapsed? It's very rare nowadays, right? Maybe not in the past, but nowadays. And compare it to how often do you hear about software breaking really bad, bad things happening because software is broken or the internet is broken. So tests cannot be considered mathematical proof, and we still have long ways to go in the field of software engineering. That's the truth. I like to see programming languages as building blocks. So just like Lego pieces, really. So each piece has individual specs. They are very well designed, but you can go vanilla and build from there. You use your imagination, or you can use a framework to help and develop things faster. But the rest is really up to you, really. What you're going to build, if it's something small, if it's something huge, if it's something very detailed or very complex, is really up to you. So the conclusion I came is that programming is art built on top of logic, just like with the Lego bricks. And this is a Venn diagram with what I believe to be 4 key qualities of a good developer: curiosity, creativity, technical knowledge, and experience. So they have kind of an axis because you start with curiosity only. That's pretty much what you have. And then the curiosity leads you to technical knowledge. And you also compensate the lack of experience with creativity. So you didn't do that before, but you're going to use all your creativity to build that solution. And with time, it becomes experience. So there is a sweet spot in the center. However, the truth is that we are always spiraling in this diagram because we are always learning new things. And curiosity will lead up to technical knowledge, and creativity will lead to experience. And then it goes on and on and on because you are always learning and gaining more experience. I'd like to finish with this quote from Andy Warhol. I really like this quote. Don't think about making art, just get it done. Let everyone else decide if it's good or bad, whether they love it or hate it. And while they are deciding, make even more art. So just replace art here with code and you're golden. Make more codes, make more open source, and let people decide, you know? And while they're deciding, make more open source, make more codes. Don't be afraid. There is a space for everybody. Thank you very much, and I hope you have enjoyed, and see you next time. Bye.